Have you ever stopped to wonder what truly happens the moment you flip a switch and light instantly floods the room? There's no delay, no waiting around, almost as if nothing has to travel any significant distance. This instantaneousness makes our brains automatically conjure an explanation, a notion that might have been deeply ingrained in your mind for ages. According to that familiar explanation, electric current is tiny electrons embarking from the power plant, traversing miles of copper wire, passing through your home's walls, and finally entering the light bulb to make it glow. This sounds perfectly logical, highly scientific, and easy to visualize, much like water flowing through pipes. However, there's a fatal flaw in this visualization, because if that hypothesis were true, your light would never be able to turn on instantly. It would be utterly impossible. Let's delve deeper into this intriguing problem. Electrons inside the wire do indeed move, but their method of travel is entirely different from what you might imagine. They don't zip along like bullets. Instead, they drift sluggishly, even incredibly slowly. In fact, in a typical household electrical wire, an electron only drifts at a mere few millimeters per second. Just a few millimeters per second. This speed is even slower than a snail's crawl, and far less than the rate at which our own fingernails grow. If an electron truly had to journey from the power plant all the way to your home, we'd be living in darkness for hours on end, or even longer, before anything happened. Yet that's absolutely not what we actually experience. You simply flip the switch and the light instantly illuminates, as if something is moving at nearly the speed of light. So we are now faced with an obvious paradox. On one hand, we're taught that electric current is the movement of electrons. On the other, those very electrons are practically motionless. Yet through some inexplicable mechanism, the effect occurs instantly. This suggests that another mechanism is at play, and it's certainly not what you've always believed. Get ready, because what you're about to discover will completely overturn everything you thought you knew about electricity. This isn't just an oversimplification, it's a profound misunderstanding of its core nature. Now let's take a moment to delve deep, to truly dissect what's supposedly happening inside a wire, because it's right here that our entire familiar picture of electricity will begin to unravel. According to the commonly accepted definition, we've always been taught that electric current is nothing more than the movement of electrons. Put simply, that's the central idea, electric charge in motion. Theoretically, this isn't wrong at all. However, the moment you try to visualize how it actually works in the real world, you'll suddenly face a paradox that very few people have ever truly noticed. Imagine a copper wire. Inside it, there's no empty space waiting. Instead, trillions of electrons are already present, long before you even touch the switch. They aren't waiting to be supplied from some distant source. On the contrary, they're already present within the metal structure, packed together like a dense crowd. When you flip the switch, you're not releasing a brand new stream of electrons from some faraway place. Instead, you're simply exerting an influence, disturbing the electrons that are already there. And this is the crux of the matter, a tiny detail powerful enough to shake the entire intuitive model we've always believed in. These electrons don't suddenly accelerate astonishingly, nor do they zip from one end of the wire to the other, as you might imagine. The reality of their movement is actually completely unimpressive. They merely drift sluggishly, constantly bumping into other atoms, losing direction, and barely moving any significant distance. If you could zoom in and see up close, you'd witness utter chaos. It's not a smooth flow, not a pure electric current, but more like a packed room full of people all trying to move but constantly bumping into each other in utter disarray. In every single moment, their average net forward movement is incredibly tiny, almost negligible. Yet surprisingly, despite this slow and chaotic movement, something within the entire system reacts almost instantaneously. When you flip the switch, the light bulb doesn't wait for individual electrons to crawl to it. It lights up instantly. So ask yourself a crucial question. If the electrons themselves are barely moving, then what is actually traveling through the wire at such incredible speed that your light bulb illuminates instantly? Because whatever the real answer is, it certainly can't be the oversimplified picture you've been taught. And that implies your most fundamental understanding of electricity isn't just an oversimplification. It's hiding a much deeper and more complex truth. It's a little-known truth that when confronted with complex problems, most of us instinctively gravitate towards the simplest solution. But is that truly the best path forward? Familiar theories often surface. Perhaps electrons are moving at speeds far beyond what we anticipate. Or could it be that electrons at the switch possess different properties than those at the light bulb? Yet upon careful examination, all these explanations simply don't hold water. The profound reason is that the very essence of the problem has absolutely nothing to do with speed. In reality, this entire misunderstanding originates from the fundamental way we've defined electric current, right from its most basic principles. We've all been taught that electric current is the movement of electric charges, and that statement is perfectly accurate. Precisely when electric charges shift, we define that as electric current. However, let's pause for a moment and ponder a remarkably subtle detail that often goes unnoticed. The crucial point to emphasize is that this definition makes absolutely no mention of how fast individual electrons must move, nor how far they travel. There's absolutely no information about the distance traveled. The definition simply asserts that the electric charge is shifting right where it is within a confined space. It's at this very moment that the veil shrouding our misunderstanding begins to lift. The reason is whenever the phrase electron flow is uttered, the vast majority of us instantly conjure a very clear and specific image in our minds. They envision charged particles departing from one point and traveling to another, much like water flowing from a reservoir through a pipe to a faucet. It's a transparent journey, a well-defined path with a clear beginning and end. However, that very mental image is subtly performing a complex function. It automatically injects assumptions that are entirely absent from the original definition. The scientific definition has never asserted that electrons are compelled to embark on a prolonged journey spanning the entire length of a conductor. And there is absolutely no data whatsoever to suggest that the electron which just left the power source is the very one that ultimately illuminates your light bulb. This is precisely the addition that stems from our individual intuition because it creates a sense of logic that is incredibly compelling and easy to grasp. Yet the truth concealed deep within holds something far more peculiar and profoundly superior. In reality, electrons within a conductor don't exist as isolated particles. Instead, they form a seamless, interconnected system, a chain already present at every point in the circuit. When you flip the switch, you're not sending an object to travel from point A to point B like a package. Instead, you're initiating an instantaneous disturbance that propagates throughout the entire network. And it's at this precise moment that deeply ingrained assumptions begin to falter, leaving us feeling unsettled as we're compelled to re-examine them. Right now, the entire notion of flow that we once deeply trusted begins to completely unravel. What truly lies behind the moment you flip a light switch? If each electron only moves an incredibly tiny distance, while the light instantly illuminates at the other end, then clearly the phenomenon you're witnessing cannot be the movement of individual electrons. In reality, it's the transmission of a form of energy or a signal, an invisible entity that glides through the entire system at astonishing speed, far surpassing the movement capabilities of any single electron. Therefore, the classic textbook definition that electric current is the movement of electric charge remains entirely accurate and without error. However, the common image in our minds of electrons racing swiftly through a wire like cars speeding down a highway does not accurately reflect the true nature of reality. It's merely a condensed interpretation, a necessary simplification, and like many simplifications, it's powerful enough to conceal a deeper physical truth. So the crucial question arises, how do electrons truly operate within the structure of a conductor? Imagine you could shrink yourself to atomic size and observe the microscopic world. You wouldn't find an orderly flow of electrons neatly moving in a single direction. Instead, the scene would be one of chaos, an almost random dance of particles filled with constant disruption. Each individual electron constantly collides with atoms in the metal's crystal lattice ceaselessly in mere fractions of a second. As a result, they are knocked off course, violently shaken, and continuously oscillate without rest. An electron might nudge forward a bit, then suddenly be pushed aside, then move backward, and only then continue to advance. Clearly, this movement is far from smooth, and its speed is not nearly as fast as we might imagine. Instead of picturing a team of athletes sprinting on a track, a more accurate image would be a crowd of inebriated people stumbling their way through a packed room. Yet hidden deep within that seemingly aimless chaos, there exists an incredibly tiny bias, a subtle push towards a specific direction. And it is this minuscule bias accumulating over time that forms the phenomenon we call electron drift. On average, electrons tend to shift forward, but this drift velocity is incredibly slow. almost negligible when compared to the speed at which the electrical effect appears to propagate. This is precisely where our common intuition is completely challenged, because all life experience tells us that the slow movement of an object must lead to a slow result or impact. For instance, if a drop of water only slowly moves through a pipe, then clearly it will take a certain amount of time for the water to appear at the other end. That is the fundamental operating principle of cause and effect that we frequently encounter in daily life. However, electric current completely refuses to obey this familiar rule. A surprising truth: while each individual particle moves sluggishly, the overall impact propagates with astonishing speed. At first glance, this phenomenon appears to defy all conventional reasoning. Trying to track a single electron is a misguided approach, an entirely inappropriate level of analysis. Instead, let's envision a different scenario. Imagine an endless line of people standing shoulder to shoulder. When the first person gently nudges the one next to them, that kinetic energy is transmitted down the line almost instantly. Each individual only shifts a tiny bit. No one has to run from one end to the other, yet the entire impact propagates through the chain incredibly quickly. And this is the closest analogy for how things work inside an electrical conductor. Each electron merely nudges the one next to it. Each such interaction isn't the particle itself moving, but rather the transmission of a disturbance, a change in state, a signal propagating through the network. Once you embrace this fresh perspective, the traditional notion of electrons flowing like water will completely vanish. In fact, what's crucial isn't how far a single electron travels, but the speed at which that disturbance propagates through the network of pre-existing charges. Let's elevate this idea to a higher level, because the human chain metaphor isn't just a useful tool, it's also astonishingly close to reality. Once again, picture that chain of people, now stretching from the power source all the way to the light bulb you want to illuminate. Each person is already in position. No one has to rush across the room, nor does anyone need to traverse the entire distance. The moment the first person makes the slightest movement, that impulse propagates instantly. One person nudges the next, who in turn pushes the one after that, creating an unbroken chain reaction. The crucial point isn't how far each individual has moved, but rather the astonishing speed at which that change propagates through the ranks. In fact, this is precisely the phenomenon that occurs inside an electrical wire. The essential thing is that electrons are already present, evenly distributed throughout every point in the circuit. When you flip the switch, you're not sending a group of electrons on a journey. Imagine this: just a tiny impulse, an initial jolt, and instantly it propagates throughout the entire network at astonishing speed. This explains why a light bulb illuminates instantly. It's not because electrons travel from the power plant to your home, but because billions of electrons already ready in the wire are simultaneously activated and interact. Each electron, much like a domino piece, transmits a push to its neighbor, creating a wave of change that propagates at a speed far exceeding the movement of individual particles. For a more intuitive understanding of the physics, imagine a pipe already filled with water. When you apply a push at one end of the pipe, water will flow out the other end with virtually no delay. This phenomenon isn't because the same water molecule travels the entire length of the pipe in an instant, but because a change in pressure has transmitted through the entire body of liquid. Each water molecule, in turn, passes on the push to the molecule right next to it. Although each molecule moves only an infinitesimally small distance, the overall effect propagates at an extraordinary speed. Electric current operates on a similar principle, but on a scale that is even more impressive and vastly more powerful. The push here isn't conventional physical pressure. It's a more abstract concept, a kind of invisible command that instructs each electron how to move. And that invisible command travels throughout the entire circuit at an unimaginable speed. Therefore, when we say electric current is flowing through a wire, we are not actually describing a flow of material particles moving from one location to another. Instead, you are witnessing an impressive chain reaction, a synchronized and perfectly coordinated adjustment of countless charges already present within the system. When an invisible disturbance sweeps through them, a deeper question arises. If the electrons themselves aren't what's moving, but rather a perturbation instructing them how to operate, then what exactly is this mysterious perturbation made of? Because this is the missing piece that even the simplest analogies cannot fully explain. The answer lies in an invisible entity, imperceptible to touch, and one you've probably never been prompted to deeply ponder. That is the enigmatic electric field. The moment you flip the switch, an electric field emerges and envelops the entire circuit, not slowly or partially, but propagating outwards at nearly the speed of light. This energy field exists throughout the space surrounding the wire and even within it, and it is the conductor that directs the movement of each electron. And that, ladies and gentlemen, is the long-hidden missing piece that completes the full picture of electric current. Have you ever wondered what truly powers the movement of electrons? It's not their inherent will, but an irresistible response to the force of an electromagnetic field. When under the influence of such a field, each electron experiences a subtle force, initiating the minute movements we commonly observe. However, what's truly important isn't the movement itself. Rather, it's the astonishing speed at which this message is transmitted to each electron. Because the electromagnetic field doesn't trudge slowly through the conductor like a physical current, instead it propagates, it diffuses powerfully throughout space like a fluctuating wave in an electromagnetic medium at an incredible speed. Therefore, when you flip a switch, you're not activating electrons for a long journey. Rather, you're creating an instantaneous change in the electromagnetic field that encompasses the entire circuit, and this change reaches the electrons near your light bulb almost immediately. Instantly, those electrons begin to move, transferring energy into the filament, and as a result, brilliant light bursts forth. Nothing needs to travel the distance from a distant power plant to your light bulb, because at that very moment, the entire system is already present, perfectly connected and waiting. All the system needs is a trigger signal, and nothing other than the electromagnetic field is that signal. And this is the moment when all old mistaken notions about electric current completely collapse. Because if the element truly propagating throughout the system is an energy field and not a flow of physical particles, then the way we say electricity flows through wires is merely an approximation or even misleading. It's just a story created for easy visualization, but unfortunately it has obscured the entire true operating mechanism. What truly operates in an electrical circuit isn't tangible matter as you might imagine. Rather, it's an invisible effect, a form of energy propagating through space, a field carrying both information and energy from one point to another. And once you grasp this truth, the familiar wire itself will appear through an entirely new lens. The wire is no longer merely a channel transporting electrons from point A to point B. Rather, it's an inseparable component within a larger system, where the surrounding space itself plays an active and crucial role in the entire process of electrical operation. Now, our story will shift to a surprising aspect, a truth that almost no one could have anticipated. Because if the electromagnetic field is the factor propagating throughout the circuit, controlling the movement of electrons, then it's very likely you're still grappling with one final deeper assumption. Perhaps you're still imagining that the energy itself is flowing inside the core of the wire, carried by those moving charges. At first glance, this seems perfectly logical, because the wire appears to be the focal point of all activity. Electrons exist inside the wire, so by common sense, energy must also be concentrated there. However, that intuition is completely wrong. The truth is, energy does not flow through the wire itself. Prepare for a mind-blowing revelation. Electrical energy actually flows around the wire. This is a profound mystery, an aspect that even many engineers rarely take the time to truly grasp or visualize. When current flows through a wire, we don't just perceive an electric field, there's also a powerful magnetic field generated by the moving charges themselves. And it's at the convergence of these two energy fields that a wondrous, almost magical phenomenon emerges. They form a sophisticated energy network, transmitting power through space, not within the copper core, but through the void surrounding it. If our eyes were sensitive enough, you'd perceive this energy as an invisible current gliding along the wire's outer surface, subtly guided by the very fields that encompass it. The wire isn't merely a conduit for energy. Instead, it acts as an invisible, sophisticated architect, subtly shaping and guiding the energy flow that sweeps through the space around it. This revolutionary idea is vividly demonstrated by the Poynting vector, a powerful mathematical tool that precisely describes the direction and intensity of electromagnetic energy flow. In a typical electrical circuit, this energy always originates from the source, gliding through the space around the conductor and ultimately converges on the device you're powering. So when your light bulb illuminates, The energy lighting the filament doesn't originate from electrons physically traveling from a distant source. Instead, it's impressively transmitted through the electromagnetic field encompassing the entire circuit, pouring into the light bulb at an astonishing speed, nearly the speed of light. However, the electrons within the wire still play a crucial role. They interact powerfully with the field, react with the material, and are key to the entire system functioning smoothly. Yet they are not the carriers of energy in the way most of us commonly misinterpret. They are merely a small piece of a much larger picture, a magnificent process that primarily unfolds in the invisible space surrounding them. And it's right here, right now, that your entire understanding of electricity will be completely revolutionized. The wire isn't a simple pathway for electrical energy. It's a guiding architect, a sophisticated boundary, a tool to shape the invisible fields gliding through space, ensuring energy is precisely transmitted wherever it's needed. What you've always believed was happening inside the wire is actually unfolding outside it. And once you've grasped this truth, there's no turning back to those old mistaken notions. Now let's reconsider the moment you flip a light switch, because with this fresh perspective, that seemingly ordinary action suddenly transforms into something utterly different. You're not opening a gateway for electrons to begin a journey, nor are you releasing anything that needs to traverse a physical distance. Do you picture electricity flowing through a wire like water through a pipe? Banish that thought immediately. In truth, when wires, light bulbs, switches, and power sources are linked, they cease to be discrete components. Instead, they merge into a unified system poised for an astonishing physical phenomenon. Within this structure, all essential electrons are already fully present, and the electrical circuit is completely established, lacking absolutely no elements. Consequently, the moment the switch is flipped, the system doesn't waste a single second distributing or transferring electrical energy throughout. Instead, the surrounding electromagnetic field automatically reconfigures its structure almost instantaneously. This change in state propagates throughout the entire circuit at near light speed, reaching every corner of the system almost simultaneously. And precisely at the moment this transformation reaches the light bulb's filament, the electrons already present there instantly begin to move. It's not because new electrons are pouring in, but rather the electrons already residing within the filament are being influenced by the electromagnetic field and propelled forward. They constantly collide with atoms, dissipating energy, causing the material to heat up intensely until it glows brilliantly. This is precisely why the light turns on instantly, not because something is rapidly traversing the wires, but because the entire system has interacted as a unified whole. This is truly a groundbreaking insight, completely reshaping our understanding of the relationship between cause and effect. You might be accustomed to believing that something must physically move from one location to another to produce a result, but reconsider. In this instance, the cause isn't a moving physical object. Instead, it's a fluctuation within the electromagnetic field, which is already simultaneously present throughout the entire system. And once you truly grasp this concept, a multitude of everyday experiences will begin to take on an astonishing, almost magical quality. Every time you charge your phone, every time an electrical circuit responds instantly, every time current seems to operate without delay, what you're truly observing isn't physical particles hurtling through wires. You are actually observing the operation of invisible fields reconfiguring themselves in space. The wires remain unchanged, the electrons are still present, but the true essence of what's happening lies within the invisible network that connects everything. And now we're going to reveal a conclusion that once you deeply ponder it, will compel you to reevaluate everything. If energy isn't transported through conductors by moving electron currents, and if what truly propagates throughout the system is an electromagnetic field, then much of what you believe you're interacting with isn't matter moving through space. Instead, it's the intricate interplay between electromagnetic fields themselves. When you touch an electrical wire, you absolutely do not feel the flow of electrons coursing through your skin. When an electrical device lights up, it's not the laborious journey of tiny particles moving great distances from one point to another as you might typically envision. Instead, what you're truly witnessing is an instantaneous, localized reaction, triggered by an invisible energy field that has propagated to that location. And once you start to view the world through this lens, you'll discover that this profound idea is present in every nook and cranny. From complex electrical systems to the smallest signals or circuits, the fundamental nature isn't the distant movement of matter, but the propagation of energy patterns through space. Yes, electrons do move, but that motion is incredibly tiny, localized, and plays a secondary role in the grand scheme of things. The fundamental nature lies in the energy field, and this will surely make you ponder deeply because the electric current you've envisioned your whole life has never actually existed in the way you've always imagined. There is absolutely no continuous flow of tiny particles running through a wire to transport energy from point A to point B. Instead, we are observing a synchronized, coordinated reaction across the entire system, triggered by invisible structures that exist even in seemingly empty space. You are not observing the movement of matter. You are witnessing the constant updating of interactive relationships. You are tracking the transformation of an energy field state, and every component in the system adjusts to that change almost instantly. Simply put, electricity isn't about the movement of objects. It's about complex connections and interactions. When you start to approach the problem from this perspective, clearly defining the boundaries between what's inside the wire and what surrounds it, or between matter and empty space, becomes incredibly challenging. The reason is that what truly transmits energy doesn't entirely belong to either of those categories. It exists in the very fabric of the connection between them. Now let's revisit the familiar saying we often hear, electric current is the flow of electrons. With what we've discovered, you might realize why that statement seems both correct and yet harbors a profound misunderstanding. Yes, electric charge does move, and yes, electrons do indeed drift. That part is an obvious truth, but it's not the primary mechanism behind the phenomenon of electricity. That's what explains what you actually observe at the microscopic level. However, that's not what makes your light bulb instantly light up, nor is it what transmits energy from the source to your device. Because the real story behind the phenomenon of electricity is much more profound and complex. A surprising revelation about electricity: what truly transmits through electrical circuits isn't electron particles, but an electromagnetic field itself. This energy field moves at nearly the speed of light, simultaneously restructuring and reshaping the entire network almost instantly. Electrons merely react locally, serving as energy carriers through their immediate interactions. Conversely, the energy itself flows through the space surrounding the conductors shaped by the circuit's structure. Thus, when you speak of current flowing, you're not truly envisioning electrons swiftly gliding through a copper wire. Instead, you're imagining a harmonious type of movement guided by fields occurring simultaneously throughout the entire system. And this is the fundamental insight you need to truly internalize. What you perceive yourself observing in the realm of physics is often merely a simplified version your intuition conjures up. It's a mental image of tiny objects moving from one point to another with clear cause and effect relationships following distinct paths. Yet reality often conceals wonders and complexities that are infinitely more profound. At times, the crucial element isn't the objects themselves, but the invisible connections that bind them together. And electricity is a perfect illustration of this principle. There is absolutely no river of electrons surging through your home's walls to power your daily activities. Instead, an invisible energy field permeates the space around you, continuously shaping how electric charges move and how energy is conducted. And once you've truly grasped this profound truth, the next time you flick a switch, it will no longer be a simple